Hi, Elle. Uh, you asked me for a video on 4-4, so I'm going to put that together for you. Don't forget, though, that a while back I asked you to do Chapter 2 test and sent you a copy of that, but I haven't seen it back yet. Make sure you get that done. And after you get that done, we can talk about the Chapter 3 test. But 4-4 is a little bit confusing, but let's try and clear things up. It's all about comparing functions and just some review on this. When we talk about the idea of slope, we said that is a rate of change. Graphically, slope is a measure of how steep a line is on a graph. But in, um, let's say, the real world applications, slope is an indication of the rate of change of something. And your y-intercept on a graph is the place where the line crosses the y-axis. But in most applications, it's really what we call the initial value, what we start with. That's important to know for comparing functions because here we're given a couple of functions. One's in table form, the other one in function form as an equation. And if we were asked a question like, which one has a greater rate of change? We want to know which one has the greater rate of change. Since we know that our slope is a measure of the rate of change, I can look to this equation and figure out what the slope is. Remember, since y is equal to mx plus b, that means that my slope is 4. I can read it right from the equation. If you're not sure about that, make sure and go back and look up some of the other stuff that we've done. But in general, y is equal to mx plus b, right, is the form that this equation's in. And m stands for our slope, and b stands for our y-intercept. Since we know that our slope is the rate of change, to find the greater rate of change for this one, right, we're going to look at what the slope is, and the slope is 4. So we know that this one has a rate of change that's 4. Okay? And the table, right, we can find a rate of change. Remember, our slope, a rate of change, our slope is always found by looking at the change of the y values over the change in the x values. And so all we need to do to find our slope is to find our change of y. How do we get from 5 to 8? Well, that's a change of 3. So if I'm building this change of y over change of x fraction, I'm going to get 3 on the top. That's my change in y. And if we look at the change in x, the change in x is 1. From 1 to 2 is just 1 difference. So this is going to be 3 over 1, and we can call that a slope of 3. So for the table, our rate of change is 3. And for the written function, our rate of change is 4. Which one is greater? Well, of course, 4 is bigger than 3, so the equation in this case has a greater rate of change. Now, we might be asked, instead of looking at slope, perhaps we'd be asked in the same situation, I wonder which one has a greater initial value. Which one's got the greater initial value, right? Well, it's easy again to go back to our equation because we know b, our y-intercept, is the initial value. So looking at the equation, we can identify 2 as our initial value for this, right? 2 is our b, B is our y-intercept, our initial value. So the initial value for the equation is 2. But we don't have an initial value in the table. Remember, our initial value is the y value when x equals 0. If our table had an entry where it was 0, that'd be easy to find. But if our table doesn't have a value for x that's 0, then we're going to have to do a little bit of thought. But we already found our slope, and we're going to use our slope to find what our initial value is, what our b is. 3 tells us that whenever x changes by one number, the y value is going to change by 3. And so as we go down here, if I go down 1, 8 went to 5, that was a difference of 3. If I go down another 1, x is going to get to 0, right? And I'll draw like another column over here. 0 for our x. That's a change of 1. So y's got to change by 3. And since it's going down each time, we'll subtract. 5 minus 3 is going to give us 2. So that tells us that when the x value is 0, the y value is going to be 2. And that's what we want. We want the initial value is the y value when x is 0. When x is 0, y is 2. So the initial value for this one is 2. So if you were going to be asked to compare these, which one's got the greater initial value, you'd say, you know what? They both started at 2. That's their initial values. So there's neither one is going to be greater. They're the same. Okay? Most of the time, one's going to be bigger than the other. But that's how you find it. Now, notice what we were doing is we were comparing a table to an equation. And in fact, the one I just did for you was actually out of your book. Here's the table of numbers that your book gave you and the equation that your book gave you. That's just that example. And the problems in your homework are going to look very similar. Eventually, when you take the Chapter 4 test, the problems will look very similar. But then your book goes on and gives you a slightly different type of problem. And here it says that there's a baseball camp, right, that you want to go to, or maybe a couple that you're looking at, and that the first baseball camp charges $18 each day and an $89 registration fee. The second camp, all you know is that 2 days are going to cost $121 and 7 days costs $236. And we're asked which one is going to have the greater initial cost. Well, it should be pretty clear what the initial cost is here, right? But we can also write that down. I'm going to write it as an equation. Y equals blank x plus blank. That's our slope. This is our initial cost. And I'm going to read the question again. It says, I'll have to cover that up. It says that they're $18 per day. That's a rate of change because it uses the per word, right? That's our key right there, per day. That's how much it's going to change every day. So that's a rate of change. So if I'm going to write an equation, 18 is going to go here. And then it says that there's an $89 registration fee. So before I even start, and I haven't even gone to the camp yet, there's an initial cost, right? An initial value. And that's going to be $89. So that goes here. So now I know that this is my rate of change. And this is my initial cost for the function, right? The question was, Which one's got the biggest initial cost? So I'm going to focus on this value from there or from the table, however you want to look at it. The initial cost was $89. That's my initial cost. But what about the other camp? Home run baseball camp, only know two things. You know that 2 days costs $121 and that 7 days is going to cost you $236. So I'm going to make a little table. I'm going to call the number of days that I'm there X, and I'm going to call my cost Y. And I know that 2 days is going to cost me $121, and that 7 days is going to cost me $236. Okay. So we're back to that same situation that we had in our previous table. I don't have as many entries, but that's okay. I only used a couple entries here, and I have a couple entries here. In order to find my initial value, I'm still going to have to find my slope or my rate of change. And to do that, we know it's the change in y over the change in x. In this case, it's how far is it from 121 to 236, and we can do that on our calculators if you'd like. The easiest way is to take this number and subtract that one. So 236 minus 121 is going to be a change of 115. So this difference is 115. And the change in x is a little bit easier to find. How do you get from 2 to 7? It's the same as saying what's 7 minus 2. There's a difference there of 5, or you have to add 5 to 2 to get to 7. Okay? So if we write those numbers into our slope fraction, we're going to have 115 as our change in y and 5 as our change in x. Let's do the math on that. We're going to take 115 and we're going to divide that by 5 because a fraction bar is just a division symbol. That's what fractions really are. They're showing division. Take the top number and divide by the bottom number. That's what it means. So our slope there is 23. That's our rate of change. In other words, we can come up with an equation for this. It's going to give us these values from the table. And we know that 23 is going to be our B in that equation. That's our initial, sorry, that's not our B. Forget it. Or reverse. Our 23 was our rate of change, wasn't it? That's going to be our M if we were to write an equation. Okay, that would be our M. How do we use this to find our initial value then? Well, again, we can think of 23 as 23 over 1. And since that's the change in y over change in x, that tells us that for every one change in x, y is going to change by 23. Okay? So, I mean, if you want to subtract it from where we're at right now, we could. I'm going to go on the other side of this table if you want and say, well, that means if I go from 2 to 1, I got to subtract 23 from my 121. And go, well, 121 minus 23. That next table entry would be 98 when it's 1. And then I'm going to subtract another 1. So I'm going to have to subtract another 23 from 98. And that's going to give me 75. Right? So there's one way you can think about it when you're doing your tables. You can just go down. The other way to think about this too is go, well, suppose I'm sitting here at 2. I know that in order to get to 0, that's going to be a change of 2. And so I could take 2 times 23, since I know that for every change of 2, then there's going to be a 23 change in my y, which means my y's, if my x changes by 2 to get to 0, my y is going to have to change by 46. So you could say, all right, I'm starting at 121, but I know when I go down by 2 to get to 0, I'm going to have to subtract 46 from 121. And notice 121. Oops. My buttons aren't working. Oh, there's an extra button there. Let's see. 121 minus 46 is still going to give us our 75. However you want to look at that, we know that the value for our initial cost is 75 on this one. Okay? Now, we'll go back to the question. It said, which camp has the greater initial cost? Well, the first camp had an initial cost of 89. The second camp, the home run baseball camp, had a cost of 75. So the first camp, Bright Future Baseball Camp, had an initial cost of 89. That's the bigger fee. So we'd say Bright Future Baseball Camp has a greater initial cost. That'd be our answer. Which one? Bright Future Baseball Camp. That's got a bigger cost. It's $89 versus 75. Let's move on to the last piece of this lesson where it just kind of leaves things open-ended for us. Open-ended? Yeah, these are questions that like your answer might be different than my answer because it just leaves things kind of open. Like, well, what do you think? You know, if somebody says, Elle, what do you think? They're not asking Mr. Fokin what he thinks. They're asking Elle. And these are kind of like, what do you think questions? Right here it says, Jack and Manny each have a savings account. The graph at left represents Jack's account. Manny deposited $500 and then withdrew $20 each even number day for 30 days. Let's compare the functions, right? Well, let's just think about this. We're not going to worry about what the book says. I'm actually going to get a little piece of paper out and go, let's try and cover that up so we're not even thinking about what they say because they're asking me compare the functions. I'm going to look at this table and try to figure out what's going on with Jack's savings account. And so hopefully you can see that over on the left side is the balance of his savings account. And across the bottom, it's talking about the number of days. And it looks to me like they've probably put all 31 possible days in a month on the bottom. So the question is, how much money did Jack start with at the beginning of the month? Yeah, and the answer should be 100, right? Because here's his balance. It was at 100 at the very beginning. The initial value in his savings account was 100. So one of the things you could say is that the initial value of Jack's account was $100. There's one thing you could say. What was happening in Jack's account? So what happened on day 6? Hopefully you see that he added money to his account. He was at $100, but on day 6 he must have deposited another $100 into his account because on day 6 through 12 he had $200 in his account. What happened on day 12? Well, on day 12, he must have taken some money out of his account. How much money? It looks like he took $50 out. Now, here's what I'm talking about. He had $100 in his account until day 6, and then he put more money in because suddenly he jumped up to $200. And he had that much money in his account until day 12, when all of a sudden the amount of money in his account dropped by $50. Okay? And it stayed that way until day, what is that? What are these counting by threes? Day 15. And on day 15, he added another $100 because he was at 150, and then he added money and he went to 250. So he deposited $150 into his account on day 15, and it stayed that way until day 21. And on day 21, what happened? Well, he put 50 additional dollars in his account because from day 21 through day 27, he had $300 in his account. And what happened on day 27? He added another $100 into his account, and now there's $400 in. So at the end of the month, how much money did he have? Well, he had $400. I know that because if I look over here on this column, it says 400, and that's how much he had on day 30, the end of the month. Okay? So that's what's really happening in that graph. Can we kind of summarize what's going on? Yes, we can. The amount of money in Jack's account fluctuated up and down. Sometimes he put money in, sometimes he took money out. So we're going to say it went up and down. The amount of money in Jack's account went both up and down. So let's recap what we said before. Jack started with $100 in his account. It fluctuated up and down throughout the month, and he ended up with $400 in his account at the end of the month. Okay, all of that information I can tell from the graph. The other thing, if we look at it in a mathematical perspective, is to say, was this or is this function of money in his savings account, is it continuous or is it not continuous? Remember when we talked about continuous versus non-continuous, and I gave the example of like a swimming pool. I said, all right, suppose that you've got this little swimming pool and you're going to fill it up. And one method you could use would be to take a bucket, and we could just fill that bucket up and then dump it in. And the water level inside that pool is going to go from one level, boom, up to another level. So if we're going to track that over time, we'd get sort of this stair-step pattern. And we called that a discrete function, which is not continuous. And then we said, well, what happens if you fill it up with a hose? You just put the hose inside that pool and you turn the water on, and then the water continuously rises. And so if we graph that over time, you'd see a nice sloped line where you have this continuous growth, this continuous rate of change as the pool fills from zero till full. Now, because it's not going in a stair-step pattern, filling a pool with a hose is called continuous. If we looked at a graph of what's going on here, with the bucket, it starts off and there's no water in the pool, and then suddenly splash, you put water in and it sits at that level until splash, you put more water in, and it stays at that level until you throw another bucket in and splash, you've added more, and you're continually adding more, and it just like continues this nice stair-step pattern where it's like it was empty, now it's got some in, pour some more in, pour some more in, more in. So this, the depth of the water in the pool is going up in a nice stair-step pattern. If you look at it, the continuous one where you've got a hose, you start off and there's no water in there, but because the hose is filling at a constant rate, you have this continuous increase in the water level. This is continuous. This is not. This is called discrete. So, thinking with those mathematical ideas in our head, we go back to this situation. Is Jack's money in his savings account going to be continuous or discrete? And the answer is it's discrete. It's not continuous. It's not making this nice line that just goes up through there with a constant slope. Instead, it's going in this weird stair-stepped pattern, but still not continuous. There are certain levels that it sits at. So we can say Jack's account is not continuous. If we look at what the book has said, it's like, well, you know what? Jack's account both increases and decreases. It's not continuous. And the maximum value is 400 and the minimum one is 100. Those are all things that we said, right? But we're comparing. In order to do that, we have to look at the other person's account. Manny deposited $500 and then withdrew $20 each even number day for 30 days. Compare the functions. What would it look like for Manny to deposit $500 and then withdraw $200 each even numbered day for 30 days? If I made a graph of this situation, and I'm not necessarily drawing it to scale, I'm just drawing this little graph. What level did Manny's account start at? Well, it says right here, Manny deposited $500. So the beginning value is not zero. On the first day, before anything happens, his account level was at 500. Okay? And then it says he withdrew $20 each even number day for 30 days. So really, I mean, if you put days on the bottom, right, and you put money in dollars on the side, we start at 500, and it's going to stay there because the first day is day one, and that's not an even number. And so for the first day, it stays at 500, okay? Now, on the second day, day two, it drops because they took out $20. I'm not going to drop it a lot, but we're going to drop it by like $20. And it stays there for 2 days because 2 days later is going to be day four. And now it drops by $20. And then it moves on for 2 days and then drops because 2 days later on the 6th, he takes out $20. And so on and so forth. Every 2 days, it drops by $20. Every 2 days, it drops by $20, and so on and so forth, right? Let's think about what's happening. Excuse me. He started with $500, and he's going down. The amount in his account decreases every 2 days. But that's not continuous, is it? It's very stair-stepped. 2 days, it's at one level, boom, drops to the next level. So it's definitely discrete. It's not continuous. However, we can probably figure out how much he has at the end by kind of writing this as a linear equation. Not that it's a line, but it is going to follow a pattern that I could kind of follow with a line. We know that's going to be y equals mx plus b if only we knew what our slope and our beginning value were. I think we know what our beginning value is. Our beginning value is $500. It's our y-intercept. It's where we started. $500, right? Every 2 days, it drops by $20. I wonder how many times it's going to drop in a 30-day month. Half as much, because there's every other day is even, right? So day one, no change, but day two, boom, change. Day three, no change. Day four, big change. Every other day. And so there's 15 of those times that it's going to drop. 30 days total. If half of them are even, then it's going to drop 15 because 30 divided by 2 is 15. So it's going to change by 15. That's really like my x. Think 15. That's the number of days. X is representing the days that it's changing. But what's my slope? Well, how much does it change each time? It's changing by $20. It says so. It says he withdraws $20 each. Remember, each is one of those key words. $20 for each even number day. So that's our slope. And we write 20 here. But is he adding to his total or is he subtracting from his total? And the answer is he's subtracting. So we're going to make this a negative 20. And we're going to plug 15 in for our x. So y is equal to negative 20. That's our slope. Going to do that 15 times. That's how many days we're going to change it. And we got to add 500 at the end. Let's plug that into our calculator. Here we go. 1. So we're going to do negative 20 times 15 plus 500 And the answer is $200. That's how much he's going to have in his account at the end. Okay. So um, we could sum up all of that stuff and write it as our answer. We're going to compare the two functions. And so remember when we were talking about Jack's account, we said, well, he starts off with $100. It's going to go up and down. It's discrete, not continuous. And he ends up with $400 in his account. What's happening with Manny's account? Well, in Manny's account, and we can, again, kind of think about the picture that we drew here. Manny's going to start off with $500. He's going to end up with $200, and it just continually decreases, but is not continuous. It's still discrete. All right. And if you look at the information that the book gave us, it's kind of the same thing. It says, well, Manny's account is decreasing. It's not continuous, so it is discrete. And it started at 500 and it ended at 200. We came up with the same things that they did. But now in your homework, who has to come up with that information? And the answer is, well, you do. And how you talk about it, how you think about it is kind of up to you. But those are the kinds of things that we're looking for when you're comparing the two. Did they go up? Did they go down? Did they go up and down? Where did it start? Where did it finish? Is it continuous? Is it not continuous? Those are the types of things that we'd be looking for in your homework. Okay? Okay. Good luck with this assignment. Again, please make sure that you're doing chapters 2 test. I sent it to you a while back. Make sure that gets done with all the work that you did on there, not just the answers, but need to see the work on that. And good luck to you. Hopefully we'll talk to you soon. Bye-bye.